Welcome, dear friends. Today we are going to learn about flow of fluids. By studying this topic, the students will learn what are the types of manometers, and students will be able to define Reynolds number, and they will be able to explain what is the significance of Reynolds number. So let us first see what exactly fluid consists of. So as we all know that around us matter exists. So what is matter? Matter is nothing but whatever thing, everything which is around you, that is called as a matter. A state of matter is one of a distinct forms in which matter can exist. There are basically four states of matters which are observed in our everyday life, and it includes solids, liquids, gas, and plasma. So these are the liquids, this is a gas, this is a plasma, and this is a solid. So from all these four states of matter, the fluid, it consists of liquids and gases. Okay, so a fluid, it is a substance that continually deforms or it flows under an applied shear stress or external force. The fluids, they are a phase of matter, or we can say it is a state of matter, and which basically includes liquids, gases, and sometimes plasmas. So how are we going to define a flow of a fluid? The fluid flow, it can be defined as the flow of substance that do not permanently resist distortion. Means what? On application of any type of shear stress, the material, if it is a fluid, it will go on flowing without giving any resistance, and it will not resist its distortion. That means depending on the intensity of the shear stress applied, the material, it will go on changing its form without resisting it. Okay, so this is a very good example of flow of fluid. You can see here the water, it is flowing, and due to that now what is the shear stress applied over here? The shear stress is nothing but the fluid is made to flow from this height to this height. Okay, so the fluid is very freely flowing, it is not at all resisting its distortion. Okay, so at a negative temperature, so sorry, at a given temperature and pressure, a fluid, it has got a defined density. Okay, and now how density is defined? Density is nothing but mass upon volume. Okay, so if even if you alter, okay, the temperature and pressure, then for the liquids there is not much change in the density, but density difference is observed in gases when you change its temperature or pressure. Okay, so in case of liquids, the density is not appreciably affected by moderate changes in the pressure or temperature. In case of gases, the density, it is affected appreciably by both changes in the temperature and pressure. Now you can observe here at low pressure and low temperature, we can say the density is less. Why the density is less? Because the volume which will be occupied by this much amount of gas, it will be less. Okay, and we know, sorry, at lower temperature the density will be more. Okay, because the volume which is occupied by this mass of gas is very small, and we know density is nothing but mass upon volume. Okay, now as volume is less, density is going to be more. Now if you heat or if you increase the temperature of this gas and if you increase the pressure, then what happens? These molecules, they get high amount of energy, and they have the capacity to occupy large volume. Okay, now in this case the volume is increasing and hence the density will decrease. Okay, so if you increase the temperature or pressure of a gas, then its density is going to decrease. Okay, so this type of change is observed in case of gases. So we can say if you change the temperature or pressure, or if you only change the temperature, or if you only change the pressure, or if you change both, then there is appreciable difference in the density of the gases. Okay, so this is not observed in case of liquids. Okay, this is very important point. Okay, so now what is a fluid? What we have said earlier, fluid, it consists of liquids and gases. Okay, now we know that gases, they get affected by changes in temperature and pressure, and hence now we will have to modify the definition of fluid. Okay, so what is a fluid? Fluid is said to be an incompressible liquid plus the gases which do not show maximum change or large amount of changes in their in their density with changes in the temperature and pressure. Only those type of gases, they are included in the definition of fluids. Okay, so fluid is said to be incompressible if a fluid is inappreciably affected by changes in pressure, but gases can be compressed. Okay, so most of the liquids, they are incompressible. So what we say now, fluids is equal to, it includes liquids plus gases. Now which gases? In which the effect due to compressibility may be neglected. Okay, and fluid is considered to be a mass of substance which is formed by a series of layers. Okay, now for example, this is a fluid. What we are saying, fluid is a mass which consists of series of layers. Okay, now this is one layer, this is one layer, this is one layer. Okay, so when you apply any type of shear stress on this substance, on this fluid, then due to that shear stress, what is going to happen? Only the layers, they get distorted. Look, the distortion is in the form of disturbance of the layers. Okay, so at the end, the fluid is relieved of the stresses that it encounters during the flow by undergoing deformation. Okay, so the fluids are the liquids and the gases and are form of matter that cannot achieve equilibrium under an applied shear stress, but they deform continuously or as long as shear stress is applied. The flow of fluids is observed while handling the materials, like handling of liquids. Okay, now handling of liquids is very easy. Why? Because transportation of the materials such as solvents, solutions and suspension, it is simple, cheaper and less troublesome than the handling of the solids in industrial operations. Then handling of solids, it is little bit difficult. So what you have to do, you have to, if you want to handle the solids, that you have to divide them and then you have to suspend it in fluid, and this makes it easy for the transportation. Okay, so we can say in this case, what we are doing, we are fluidizing the solids. Okay, so during handling, behavior of the liquids changes transiently, and the changes in the liquid, uh, due to this, there occurs, it has effect on the heat transfer process. It also affects the energy losses during pumping, and it also affects the energy changes required during pumping. So the fluid flow is involved in a number of areas in industry. The first is when you transfer the air of the nutrient broth into the fermenter, when you pass the reactants, the liquids or the gases into reaction system, or when you go for filling of the liquid, that is the dosage form medicaments, into suitable containers, or during transporting the sterile air and sterile water during the production of pharmaceuticals. Also, it is involved during mixing of solids and liquids in case of suspensions, and also it is very important in case of packing of semi-solids in the containers. Okay, so now the nature of the flow, it influences what type of equipment you have to use for handling, what type of pump you have to use, what should be the capacity of the pump, what should be the diameter of the pipe, etc. It all depends on the nature of the flow. How is your flow? Okay, so the flow through the pipes and channels, they are relevant. The measurement of rate of flow is necessary for quantification of additives into a process. Hence, fluid flow, it has emerged as a special branch in science. The fluid mechanics, it is a branch of the science which deals with the behavior of the fluids both at rest as well as when the fluid is in motion. Okay, so now again the fluid mechanics, it has got two branches. The first one is the fluid statics. Now the name itself is going suggesting that statics means what? Means at rest. Okay, so it tells us that it is the study of the fluids which are at rest and which are in equilibrium. Okay, and fluid dynamics is another branch of fluid mechanics, which tells us that it is nothing but it is the study of the fluids when the fluid is in motion. Okay, now when the fluid is water, at that time the concept of fluid statics, it is also termed as hydrostatics. Okay, so fluid, now we will see first what exactly fluid statistics involves. Okay, so fluid statistics, it mainly deals with the fluids which are at rest and are in equilibrium. What are the some aspects of fluid statics? That the behavior we are going to study, or we are going to only talk about the behavior of the liquid at rest, and we will be talking about nature of the pressure it exerts and variation of the pressure at different layers. Okay, now we are going to study what type of pressure is exerted due to that layer, and in every layer the pressure is different. Okay, now why that pressure is different, that we will see it later on. Okay, so the study of the fluids at rest is based on two principles. The first is pressure at a point is same in all directions, and the second principle is pressure is same at all points in a given horizontal line in a continuous fluid. Okay, so consider this to be as a beaker and which is filled with water. So what we are saying, what are the two principles? The first is pressure at a point is same in all directions. Means what? Consider this water molecule. Okay, now the pressure which will be acting from all the four sides on that molecule, it will be same in its intensity. That means the pressure from this side, the pressure from this side, the pressure from this side, from all the four sides, the pressure which is acting on that particular molecule is same. Okay, now what is the second principle? It states that the pressure is same at all points in a given horizontal line in a continuous fluid. Okay, now suppose this is a line and these are the molecules which are on this line. Okay, so now what we are saying, the pressure which will be exerted on this water molecule, the pressure which will be exerted on this water molecule, and the pressure which will be exerted on this water molecule, it is same. Okay, so all this they will experience same pressure. Okay, so let us see the pressure difference between layers of the liquids. Okay, so pressure, how do we define pressure? Pressure, it is defined as the force exerted per unit area. So we can write it as pressure is equal to force upon unit area. Okay, so how we can write force? We can write force is equal to pressure into area. Got it? Okay, now consider a column of a liquid as shown in the figure. Okay, now this column, it has got two openings. Okay, the two openings, they are made into the column wall at different levels. Okay, you can observe this is at a higher level as compared to this opening. Okay, so now what we are going to learn, we are going to see how is the rate of flow from these 2 points. Okay, so just if we visually observe it, from the nature of the flow, we can make it out that the rate of flow over here is different and the rate of flow at this point is different. Okay, so now why this rate of flow is different? This is due to the difference in the pressure which is exerted at different height. Now who is going to exert the pressure? The liquid column. Okay, the liquid which is over here above this opening, and the liquid which is above this opening. Okay, this liquid is going to exert pressure. Now what we are saying, at different layers the pressure is different. Okay, so as we if we say that this fluid is moving in this layer and this fluid is moving this layer, so these two we will consider as to be different layers, and hence the pressure over here is different and the pressure over here is different. Now why the pressure is different? Because of the height. Okay, you have to keep in mind the pressure is different because of the height difference. Okay, right? So you can perform this experiment at your home as well. You have to just take a bottle and you have to make 3 openings into that bottle. So what you observe, the 3 openings, they have to be at different levels. Okay, so the rate from at which the fluid is moving through this point is very high, then this is intermediate, and this fluid flow is very low. The velocity, the rate of flow is low. Okay, so this is the basic principle. Okay, now what you have to do, you have to consider a column of a liquid as shown in the diagram. Okay, now consider the column of the liquid and consider that pressure of PS Pascal is acting on the surface. Okay, from here pressure PS Pascal is acting on the surface. Okay, at point A pressure P is applied. P is also in pascals. Okay, and why this pressure is applied? To maintain this column stationary. Okay, now we will say the area of this column is S. Okay, it is uniform. The same area is here, the same area is here. Okay, so the force acting on the liquid at different levels, it can be determined. For that you will have to consider 2 points, point 1 and point 2. Okay, now what we are going to say, the pressure or the force which act on point 1, they are nullified. आता कुठले कुठले force या case मध्ये nullify होणार आहे? The force which acts in this direction, from the right hand side and from the left hand side. Okay, it gets nullified. Okay, so which force is going to mainly act on point 1? It will be the force which is acting above that point and the force which is acting below that point 1. Okay, so those two are only the forces which are acting on point 1. So now what we are going to write, that force acting on liquid at point 1 is equal to force on the surface and the force exerted by the liquid above point 1. Okay, now above point 1 there is some liquid, and obviously liquid has got some weight, so it will exert some type of force on that point 1. Okay, so what is the total force acting on liquid at point 1? It is the force, that is PS pascals, which we have applied externally, and it is the force which is exerted by the liquid which is above point 1. Okay, so let us consider this to be as equation 1. Now substitute the force with pressure into area of cross section in equation 1. So we will write pressure at point 1 into its surface area is equal to pressure on the surface into area plus mass into acceleration. Now why mass into acceleration? What will be the force which will be exerted by that liquid? It will be exactly equal to the weight of the liquid. And how we are going to write the weight of the liquid? Mass into acceleration, right? So we will just designate it with some letters, and so we will say P1S is equal to, P1 is nothing but pressure at point 1, is equal to PS into S plus volume into density into acceleration. Okay, now do we have the mass? No, but we know what is the density of water. Do we have volume? Yes, we can calculate from that column. Okay, so we know density is equal to mass upon volume. Okay, so how you can write mass? Mass is equal to volume into density. Okay, so here this mass is further simplified as volume into density. Okay, so now we will again write P1S is equal to PS into S plus height into area into density into acceleration. Now from where did this height into area came? From the volume. We are simplifying now. The formula for volume is height into area. Okay, so now we will write this equation as P1S is equal to PS into S plus H1 S rho G. Rho is the density, G is the acceleration due to gravity, S is the area, H1 is the height. Okay, now we know that the surface area is going to be same on all sides, so this quantity of S, it will get cancelled on both the sides, and we will get P1 is equal to PS plus H1 rho G. Okay, now we know this is the equation for pressure at point 1, so we will write the same equation for pressure at point 2, and it is written as P2 is equal to PS plus H2 rho G. Now what is changing here? Only H1 and H2, only those two things are changing. Your density is going to remain same, and your acceleration due to gravity, it is going to remain constant, and pressure what we have applied, that is also constant. Okay, so the difference in the pressure, it can be obtained by minusing the two equations. Okay, so P2 minus P1, we will write it as PS plus H2 rho G minus PS plus H1 rho G. Now this is equation 2, and this is equation 1. Okay, so we get P2 minus P1 is equal to PS plus H2 rho G minus PS minus H1 rho G. Okay, now we can write it, pressure difference is equal to H2 rho G minus H1 rho G. Now we will take out the similar terms on one side. So we can write delta P is equal to delta H into rho G. Okay, so we can say the pressure difference is related with the height difference. Okay, so pressure difference, that is delta P, in between any 2 points can be measured by measuring the difference in the height in between those 2 points of the fluid. Okay, so as the difference in densities is negligible with the difference in pressure, difference in height is necessary for measurement. Height is measured from bottom of the column, so we can say pressure difference is directly proportional to height difference. So pressure is expressed in terms of height. Now what is the application? This principle of static fluid is used in the working of manometers. Okay, so pressure difference is measured here in terms of difference in the height of the liquid column. Okay, also it is applied for a quantification of fluid flow as in Bernoulli's theorem. Okay, so now first we will see what is a manometer. A manometer, it is a device which is used for measuring the pressure difference. Okay, so pressure differences, they are based on the principle of balancing the column of a liquid by the same or another column of liquid. Okay, means you can use same column of liquid or different liquids. Okay, so different type of manometers are available, and it includes simple manometer, differential manometer, and inclined manometer. Okay, so first let us see what is a simple manometer. It is a device which measures the pressure at a point in a fluid contained in a pipe or a vessel. Okay, so it is a manometer. You have to keep in mind it will be measuring only the pressure at a single point. Okay, in a fluid which is flowing through a pipe or a vessel. So this manometer is the most commonly used one. It consists of a glass which is U-shaped tube and which is filled with the liquid A, and it has got density rho A kg per meter cube, and above A arms, above the liquid A, the arms are filled with liquid B. Okay, so again the density of liquid B will be rho B kg per meter cube. Okay, so liquid A and liquid B, they are completely immiscible, and interface in between these two liquids, it is clearly observed. Okay, now this is a simple manometer. What does it consist of? It consists of a U-shaped glass tube. Okay, and this glass tube, it is filled with two type of liquid A and liquid B. Okay, the lower one is the liquid A and the above one is the liquid B. Okay, so you have to keep in mind that these two liquids, liquid A and liquid B, they are completely immiscible, and the interface in between these two liquids is clearly visible. Okay, so if two different pressures, they are applied on the two arms of the meniscus of one liquid, then meniscus of one liquid will be higher than the other. Okay, so let the pressure difference at point 1 be P1 pascals and point 5 will be P2 pascals. Okay, so this is point 1 and this is point 2, this is point 3, this is point 4, and this is point 5. Okay,
Now let the pressure at point 1 be P1 pascals. Let the pressure at point 5 be P2 pascals. Okay, you can see at point 3 and point 3 and point 2, they are at the same level, and point 4 is at the meniscus of liquid A and B, but it is on the right hand side arm. Okay, so the dark blue is the liquid B and light blue is liquid A, as we have seen earlier. And the difference or the height in between, or the length from point 3 to point 4 is expressed as R, and the height or the length of point 4 to 5 is expressed as M. Okay, now we can write pressure at point 2. Okay, so this is our point 2. If we want to write pressure at this point, then how are we going to write? P1, that is the pressure which is acting on this arm, plus MR. Okay, now the level of point 2 is equal to level of point 3. How we can write the level of point 3 from this meniscus? It can be written as M plus R. Okay, so same way we can write the distance of point 2 from point 1 as M plus R. Okay, so that is the height, and rho B is the density of this liquid into G. Okay, now we have written this formula from the one we have derived for fluid statistics. Okay, so here in this case, as I told you, M plus R is nothing but it is the distance from 3 to 5. Okay, since point 2 and 3, they are at the same pressure, same height same है म्हणजे pressure same है, so we can write pressure at point 3 as P1 plus M plus R rho Bg. Okay, now the pressure at point 4, okay, from right side of the limb, it can be written as P2 plus Gm rho B. M is the distance. Okay, or from the left hand side, it can be written as P1 plus rho B M plus R G minus rho A R G. Okay, now why we have minus this R? Current that distance kiti hai M. Okay, so we have minused it. Okay, so the equation 2 and 3, this equation, they represent the pressure at point 4 only. Hence we can equify all its on it both sides, and if we equify, then finally we can write it as P1 minus P2 is equal to Gm rho B minus Gb rho Bg into M plus R plus rho Arg. Okay, now we can simplify it further. Okay, we can write P1 minus P2 as delta P, and we are going to open this bracket. Now if you open this bracket, we can write it as Gm rho B. This value is going to remain constant. Rho Bgm minus rho Bgr plus rho Arg. Okay, now you have to look carefully at this equation. This same figure is going to get minus from this, because here minus sign is there. So we are going to cancel it out, right? So after cancelling this, what is remaining with us? This negative sign, we will take it on this side. So we can write it as delta P is equal to R is common, we have taken it outside, G is common, we have taken it outside, and we will write rho A minus rho B. Okay, so now we can say the difference in pressure is related to the difference in density. So it is easy here to measure the R value. How you are going to measure the R value? Directly from the limb, it is graduated. Okay, so you can measure the R value in meters, that is difference in the level of the liquid A into limbs, and value delta P pascals is independent of the value of M and also the dimensions of the U tube. Okay, so when wide range of pressure is applied, then sensitivity of the liquids employed in the measurement is very important. Okay, so if pressure difference is large, then mercury can be used, and it has got low vapor pressure. Also, it is non-corrosive and do not react with the fluids whose pressure is to be measured. As it has got low viscosity, it gets adjusted very fast. So mercury manometers, they can measure pressure change in the range of 0.5 centimeters to 17 centimeters. The liquids like benzene, they have got high vapor pressure and they are volatile. Okay. So the U tube, it is mounted on a wooden stand, and as I told you, it is a graduated scale in mm. It is fixed in order to measure the height. Height directly gives you the pressure. So if pressure difference are small, liquids like alcohol, water and carbon tetrachloride are also used. Okay. Now what is the application of the simple manometer? It helps in measuring the consumption of gases in the chemical reactions. It is used along with flow meters and orifice meters for measurement of the pressure head using manometer. Also, it is used in pitot tubes to measure the velocity head. Okay. So now we will see the next type, and that is differential manometer. The differential manometer, it is a manometer which measures the difference of pressure between any 2 points. Okay. Now you have to keep in mind the simple manometer was going to measure the different pressure at only one point. Here, the differential manometer, the name is suggesting it is going to measure the difference of pressure in between any 2 points in a pipe or vessel containing the fluid. So occasional application, it has got occasional application. These manometers, they are suitable for measurement of small pressure differences. That is, hence it is a very sensitive device. It is also known as two fluid U-tube manometer. It contains two immiscible liquids A and B having nearly same densities. Okay, there is small difference in between densities. Okay, the U tube, it contains enlarged chambers on both sides. Okay, now if you see the construction of this type of manometer, you will observe that here it has got a little enlarged area. Okay, it is just similar to your our simple U-tube manometer. The only difference is it has got this two enlarged areas. Okay, now um, here the simple manometer, it contains liquid C, liquid B and liquid A. Okay, so different points are given and different heights are given, and also different pressure is applied on the two surfaces. Okay, so using the principle of simple manometer, the pressure differences can be written as delta P is equal to P1 minus P2 is equal to R into rho C minus rho AG. This smaller is the difference in between the two densities, the larger will be the value of the manometer for given value of delta P, and hence it is called as sensitive. Okay, now what is the application of differential manometers? Micromanometers, these are based on liquid column principle and they are available commercially. You can take the reading with extreme precision and sensitivity, sensitivity, and it is free from errors due to capillaries and require no calibration. Okay, now we will see next what is inclined tube manometer. The inclined manometer, it is a manometer which measures the minute pressure difference between any 2 points in the fluid which is contained in the pipe or vessel. Now inclined manometer is going to get the minute pressure difference. Okay, so it is, we can say it is a modification of differential manometer. It has got increased accuracy, and this is the diagram for inclined manometer. Okay, now you can observe here that at one limb it has got an enlarged chamber and the height difference is not so visible. Okay, because of this enlarged area, but the other limb, it has got very narrow surface area, and due to that even smallest height difference is achieved, then it is very significant. Okay, due to very small pressure also the height difference is very significant. Okay, now you can measure the difference in pressure by using this formula. PA minus PB is equal to R1 sine A into G into rho A, rho B minus rho E. Okay, now what is sine A? Sine A is the angle. Okay, now what you're going to do, if you lower this angle, you can move this inclined arm. If you lower this arm, then what will happen?
this value of A is going to decrease. Okay, if you increase this angle, the value of A will increase. Okay, so automatically if you increase the angle, you will get very good results. Okay, because the pressure difference will be very significant by difference in the, by observing difference in the height. Okay, so here a vertical leg is enlarged, so that movement of meniscus in this enlargement is negligible. But containing one meniscus is inclined, this is inclined, so that for small value of reading R, the meniscus will move a considerable distance along the tube. The distance is equal to R, that is, it can be observed vertically, and it is divided by sine of the angle of inclination. Okay, sine A. So making angle A small, value of R is increased. Okay, so now we will see what is fluid dynamics. Fluid dynamics, it deals with the study of the fluids which are in motion. Okay, so this knowledge is very, very important for the liquids, gels, ointments, which will change their flow behavior with exposure to different stress conditions. Okay, now the whenever liquid or a fluid, it is in its manufacturing state, then um, uh, the rate of flow, okay, is different, its behavior is different. Why? Because of mixing. Then also we carry out we make the fluid to flow through the pipes, we bring about filling. Okay, so it is going to the flow changes, it affects the selection. Okay, so during all these operations, the flow is going to change because different type of stress is being applied on that particular fluid. Okay, and the flow change, how will be the flow change, that is going to determine what type of mixing equipment or what type of equipment you should be selecting. Okay, so also the force, it the fluid property, it changes during handling of the drug or during administration as well. Okay, so now when you the
So during handling, like during administration, okay, so syringeability, pouring of the liquids, extrusion of the ointment from the tube, it all depends on the changes in the flow behavior of the dosage form. Okay, so the flow of the fluid through a closed channel, it can be either viscous or turbulent, and it can be observed by Reynolds experiment. Okay, Reynolds experiment tells us that when you take a tube and you allow water to flow through it, and if you insert a colored water stream inside that tube, then what will happen, depending on the flow, okay, depending on the flow rate of the colored solution, you can observe two things. Okay, the first is, if the rate of flow is minimum, it is lowest, then the colored water, it will flow as it will has a streamline flow, it will not get mixed with uh, the next water layer. Okay, so, and um, uh, this two means colored water and non-colored water, they will flow just like that without getting mixing for a long period of time. Okay, now here we can say that as there is occurring no mixing, we can say the fluid, it is in laminar flow or it has got viscous flow. Okay, now consider this, if you increase the rate of flow of the colored solution at this point, then what is going to happen, you will get a turbulent flow. Okay, there is a random path over which the colored solution is moving, and this colored solution, it will get mixed all over, it will get mixed with the liquid, and finally you will not get two distinct um, streams of water. Okay, so in this way, when we have this type of fluid flow, it is said to be turbulent flow, right? Okay, so consider a glass tube which is connected to a reservoir of water. The rate of flow of water is adjusted by a valve. Then a reservoir of colored solution is connected to one end of the glass tube with the help of a nozzle. colored solution is introduced into the nozzle as fine stream. The rate of flow of water, it can be increased or decreased. Okay, so you can draw conclusions. The first is when velocity of water is low, the thread of colored water, it maintains the identity throughout the tube. If we introduce similar colored jets from different points, we notice that no part of the tube, it is going to show the signs of mixing. Okay, hence the colored streams, they are seen as parallel lines. Okay, here the flow is considered to be viscous or streamline or laminar. The laminar flow is one in which the fluid particles, they move in layers, laminar layers, with one layer sliding over the another. Okay, so this is laminar flow. So you'll observe here that when the fluid is flowing in laminar flow, there is no exchange of fluid particles from one layer to another. Hence the transfer of lateral momentum to adjacent layer is not observed. Okay, and there occurs no mixing. When velocity of water is increased, the thread of the colored water, it disappears, and mass of the water gets uniformly colored, and this indicates complete mixing of the solution, and the flow of the fluid is called as turbulent flow. Okay, so when flow attains a certain velocity, it no longer remains steady, and vortices or eddies, they appear in this type of flow. So due to that vortices and eddies, the flow is not laminar, but the layers, they get all mixed up. Okay, so all fluid particles, they are distributed and they get mixed up with one another. So there is continuous transfer of momentum to adjacent layers. So this diffuse flow is said to be as turbulent flow. The velocity at which the fluid changes from laminar flow to turbulent flow is called as the critical velocity. So we can define critical velocity as an average velocity of any fluid at which viscous flow changes into turbulent flow. Once critical velocity is crossed, the shear stress is so great that streamline flow breaks down. The fluid gets random radial velocity. Mixing occurs due to formation of eddies. Okay, so Reynolds number indicates, or it gives us some types of conclusion. Okay, so in Reynolds experiment, the flow conditions, they are affected by four factors. The first is what is the diameter of the pipe, what is the average velocity of the fluid, what is the density of the liquid, and what is its viscosity. Okay, so these four factors, they are grouped into an expression, and that is called as expression for the Reynolds number, and it is given as Re is equal to d mu rho upon viscosity. Okay, so Reynolds number is obtained by following equation. We can say Reynolds number is equal to inertial forces upon viscous forces. Now what is inertial force? Inertial force is nothing but mass into acceleration of the liquid flowing. And what is viscous force? It is shear stress into the area. Okay, so inertial forces, they are due to the mass and the velocity of the fluid particles which are trying to diffuse the fluid particles, and viscous force is the frictional force due to viscosity of the fluid which makes the motion of the fluid in parallel layers. So at low velocities, inertial forces are less as compared to the frictional forces. That means what? When the velocity is less, at that time, the inertial force is going to be less. Okay. And what will be more? The viscous force will be more, and hence we will get a very viscous flow. Okay. So the resulting flow will be viscous in nature, that is, particles will move in parallel layers. Okay, hence laminar flow is also called as viscous flow. Now when inertial forces, they are predominant, the fluid layers, they will break up due to increase in velocity, and hence turbulent flow will take place. Okay, So now if Reynolds number is less than 2000, then at that point, the fluid is said to be laminar flow, is said to have laminar flow. Okay. Now when the Reynolds number is above 4000, at that time the type of flow is said to be turbulent. Okay. Now when the Reynolds number, it lies in between 2000 to 4000, the flow changes in between laminar to turbulent. Okay. And this particular region of 2000 to 4000 is said to be critical region. Okay. So turbulent flow, it exists at all Reynolds numbers which are greater than 2100. Okay. So what is the application of Reynolds number? Reynolds number is used to predict the nature of the flow, that is if it will be viscous or turbulent in a particular set of experimental conditions. Also it helps to determine physical stability of the suspensions or emulsions, as it depends on the rate of settling of the particles or the globules. So for study of rate of sedimentation, Stokes law is used. Here the rate of sedimentation of particle, it must not be too rapid to create turbulence. So the type of flow is very important, and hence Stokes' law is modified to include the Reynolds number. The rate of heat transfer in liquids, it also depends on the flow, if it is viscous or turbulent. Now, what is the variation in the velocity of flow across the cross section? When local velocity is plotted against distance from the wall, following conclusions are drawn. The first is the flow of the fluid in the middle of the pipe is faster, okay, than the fluid which is near to the wall. Okay, so the velocity of the fluid, it approaches zero as the pipe wall is approached. Okay, so at actual surface of the pipe wall, the velocity of fluid is zero. Okay, so since there is variation observed in the velocity of the flow across the cross section, of some estimates are made for average velocity. Okay, what estimates are made? In viscous type of conditions, average velocity over the whole cross section is 0.5 times the maximum, and in turbulent flow, average velocity over the whole cross section is 0.8 times the maximum. As the velocity of the fluid is zero at the wall surface, there should be some layer in viscous flow near the pipe wall which act as stagnant layer. Even if the flow is turbulent at the center of the pipe and viscous at the surface of the wall, a buffer layer is present in between turbulent and the viscous flow layers. Okay, so there is a gradual transition from one region to another. There exists a boundary layer, and this is known as the buffer layer, and it oscillates in between viscous flow and turbulent flow. Okay, so the boundary layer, it can never be eliminated. Increasing the velocity of the fluid will reduce the thickness of the stagnant layer and the boundary layer, but it will never be eliminated directly. So this was all about manometers, flow of fluids, and Reynolds experiment. Thank you for watching.